Hey folks, Darren with Fervent Astronomy. Today we are following down the rabbit hole of my fisheye lens obsession with the Sigma 10mm f2.8 DC HSM fisheye lens. This is a 180 degree fisheye lens for APS-C sized sensors. And why? Well, why not? I've been on the hunt for a fisheye lens where I can get a circular field of view and have it be fast enough for astrophotography, and I think this is the ticket. First of all, it's an older DSLR lens, so it's nice and chunky, nice and heavy. It has a manually coupled focus ring here that does do override, so it will override the autofocus, but there is an AF/MF switch there. Rear element lacks a gasket. This is the Nikon F mount version, but it was available for Canon EF mount, and I'm sure basically every other DSLR that existed. And yeah, so this is a little bit embarrassing. I got this off eBay. It's like pristine condition, right? And based on my experience with the Sigma 15mm diagonal fisheye, in that lens, the hood, you can remove it, but you have to strip the whole lens down from the mount all the way to the front. So that's where I started, because I couldn't find any information online, couldn't find another teardown or anything. That was not the way to go. I mucked up the hyperfocal distance indicator a bit, which is just aesthetic, but it hurts me. I lost and then found a bunch of tiny little ball bearings, because for some reason it's got this ball bearings. It just, why? And then finally, after I just stripped the whole lens, I realized that the way you remove the hood is by accessing the front of the lens. So I did turn it into a circular fisheye lens. You just use a rubber lens wrench, and it's like glued in place a little bit, but you can unscrew that front element, and just right under there are 4 screws that take the hood off. It's a metal hood as well, so it's not really something you can go at with an X-Acto knife. So yeah, pretty easy to remove. Learn from my mistakes. This, as far as I know, is the only information of this type on the internet right now. So that's kind of frustrating. At any rate, successful. Why would I do this? Let's get something out of the way first. We've got a plastic pinch cap, and then a basically tube for a lens hood. However, this is a 67mm lens cap, and you can actually screw filters onto the front of this hood. So if that's something that you needed or wanted to do, you can do so. But why did I go circular? Because I really am obsessed with it for some reason, and I wanted a fast circular fisheye. So this is 180 degrees on an APS-C body, f2.8. So when you put it on a full frame body, to be honest, it doesn't get quite circular, but it's much better than any other alternative. That being said, if you put a focal reducer on this lens, a speed booster, and use it with a mirrorless camera, you can boost that aperture, I think, to 2.2 or f2, I can't remember. It's a 0.71 multiplication, but you also compress that image circle down, and then you do get a circular fisheye for your full frame camera, and I'm pretty happy with that. So why would I want that? Well, time lapses are something that I do. I am connected with the ability to maybe project said 360 time lapses on a planetarium dome. So that's something I'm interested in seeing if it's possible. So yeah, and it's just cool. Can't things just be cool? Don't judge me. Okay. You can judge me. Just do it silently. Anyway, this is getting ridiculous. Let's pop into Lightroom and see how this lens performs. Hey folks, welcome to Lightroom, and join me on my quest to do something very specific and very silly. That is to get a circular fisheye that's faster than f2.8 on a full frame camera. Of course, we've recently seen the amazing Sigma 15mm fisheye, f1.4, 180 degree fisheye. It's great, but I want more degrees. I want all of the degrees, not just corner to corner. And so I don't know why I have a fascination with fisheye lenses, but I do, and here we are. So this is the Sigma 10mm f2.8 DC fisheye. This was an APS-C fisheye lens, supposed to be 180-degree corner-to-corner fisheye lens for APS-C cameras, released a long time ago. It's an old lens, and this lens I managed to hack my way into becoming a full circular fisheye that is faster than F2.8. First couple of things, these samples are taken with the Sony a7R Mark V 60 megapixel camera. The 60-second exposures here are tracked, and they're tracked to the Fornax Mounts LighTrack II. Fervent Astronomy happens to be Fornax's North American distributor. If you're interested in learning more about that mount, head on over to ferventastronomy.com and you can do so. All of these samples are taken at the a7R Mark V's second base ISO of 320. Why 320? Well, this camera is ISO invariant, and if you want to learn more about that, you should be getting a link popping up at the top-ish of the screen around now, or if you'd like, in the description, there's a link. It'll bring you back to our website, and you can find a link to a good article that will explain in minute detail everything about ISO invariance. And while you're there, you can actually get a link to all these samples, full raw, so that you can pixel peep to your heart's content, do all that good stuff. I would just ask you, I am the copyright holder for these photos. I've had to buy the lens, put in all this legwork, I had to make the review, so please only use these samples for the purpose of assessing the lens and nothing else. Please and thanks. So I have a few different ones here. We've got tracked samples going through the aperture range. Then we have an untracked 15-second exposure to show you what you can expect if you're just trying it on a tripod. Then we've got these ones which are obviously circular fisheye. I'm using a Metabone speed booster for these, Canon EF mount to Sony E mount. Although, not to confuse things, the lenses themselves were released for DSLR mounts, so you can find them for pretty much every kind of mount. Although in my case, I think I was only able to find a Nikon one at the right price. And I've actually used a Nikon F to Canon EF adapter to then adapt the lens to the EF to E mount speed booster, and it's kind of a mess, but it works. And what that does is that puts an extra lens element in between the lens and the camera, and that's called a focal reducer. A speed booster is a focal reducer. And what it does is it takes that image circle, in this case meant for an APS-C camera, and it actually compresses it, and it will concentrate all that light into a smaller area. This is supposed to be for the opposite of what I'm doing. You're supposed to use this with full frame lenses to actually compress them into the footprint needed for an APS-C camera so that you can get the same field of view that you would if you were using the lens natively on full frame. I'm hacking it, and I did some experiments and stuff to figure out that I needed around a 10mm fisheye lens so that when I compressed it with the speed booster, I was compressing the image circle within the bounds of the full frame sensor while not, doing it too much and wasting some space around the edges. And as a bonus, we do speed the actual lens up. So it goes from being an F2.8 lens to actually bringing in F2 amount of light. I'm a big nerd for this. It's silly. What are you going to do? Let's look at these samples here. There was a lot of aurora this night. Here it's just kind of hovering on the horizon, but it was overhead for a lot of it. And it's kind of annoying because I was trying to test a bunch of lenses, and you'll possibly, if you watch some other reviews, stumble across various reviews where everything's green because I just pushed through anyway because it wasn't that important. But anyway, this is wide open at F2.8, 10mm, 60-second exposures. And here we see we cut a little bit off the top and bottom of the frame, not quite 360. I don't think it's obviously too useful to talk about vignetting with a fisheye lens, so that's not really anything to worry about. And here we're already so slow at 2.8, I wouldn't really want to stop down at all. You're gonna lose valuable light, but if you wanted to, you could do so. This is 2.8, this is 3.2, and you're maybe darkening up the center a bit, maybe increasing some contrast in the center, but I'm not convinced that it's worth it. 3.5, F4, and again, this is 60-second tracked exposure, and we're getting quite dark, so not convinced that it's 100% worth it. If we come into the center of the frame, we'll see that things are maybe a little bit soft, not super, super sharp. It's an old lens and et cetera, et cetera. And there is a little bit of color fringing, but it's not terrible, honestly. And if we stop down, 3.2, right away that fringe kind of goes away, and we are getting a little bit more darkness here in the center. I think we're probably getting rid of some of that stray light. Again, your mileage may vary whether or not it's worth it. 3.5, not a ton of difference. F4, you're getting pretty crunchy here. You can see you got a lot of noise coming in, so 2.8 might be where it's at. Look down here at Orion. Here we can see that there is a lot of astigmatism. Lots. It looks very cool, actually. A little bit retro, a little bit modern. It's got sort of a cyberpunk aesthetic to it. It's great. But obviously, these are not round stars. That being said, you wouldn't really notice from here, would you? That's the magic of a fisheye. Things are so distorted that it does hide some of this. So this is astigmatism. This is not coma, as some of you might be thinking in your minds. What astigmatism is you can imagine along any radii that comes from the center to the edge of the frame, wherever there's a star, the lens is having trouble focusing that light into a pinpoint. It's a pinpoint of light, but it's having trouble focusing it into a pinpoint. So it'll stretch out in two directions usually. So this direction along that radii from the center, that's called tangential astigmatism. Orthogonal to that, so at a right angle, you'll get sagittal astigmatism. And sagittal astigmatism will sort of look more like it's ringing the frame. And that's kind of what I think you're seeing here. And then the tangential sort of stretching out along this radius. It is what it is. It's pretty common here with a fisheye lens, and especially an older fisheye lens. That's what I would have expected, to be honest. Let's cycle through the apertures. F2.8, 3.2, barely a change. 3.5, F4, like barely a change. That sagittal astigmatism is maybe folding in a little bit, but I don't think it's worth stopping down based on that at all. And when it comes to fisheye lenses, it's a little hard to assess for some other things. For instance, field curvature. I can't say that the stars here are in focus or out of focus more than the ones in the center. There is a significant amount of astigmatism that's kind of masking that. So I don't think it's necessarily an important question to ask, basically. As well as some other stuff, such as aperture vignetting. I don't think that's sort of a relevant thing for fisheye lens, especially. I'm not seeing any coma. And what we just showed was astigmatism. You'll remember coma or chromatic aberration, something else. It leads to some little bit of fuzzy bits on one side of the stars, either all pointing away from the middle of the frame or towards. You might argue that there's a little bit here, but I would also argue that even if it is, it's irrelevant. And yeah, essentially distortion. Yeah, there's tons of distortion with the fisheye lens. You get it too. So yeah, basically it's a fisheye lens. So far, that's what we've landed on. Here, this is a 15-second untracked exposure with the A7R Mark V and wide open at f2.8, 15 seconds. Yeah, I'm not really seeing any trailing. We are, of course, getting the stretching due to that astigmatism, but yeah, I'm not seeing star trailing. These are about as small as the stars can get. So I would say, even though it's a 60 megapixel camera, you'd be safe to push the exposure longer here. Let's take a little peek here at the circular version here. So all this is going to be wrong. It's not shot at f1. The camera basically doesn't know it has a lens on it by this point. But yeah, here we're now essentially shooting at f2 and we're getting that full 360 degrees. We can zoom in on the center. It looks pretty close to the same, to be honest. We still got that fringing. Keep in mind, we've added glass to the lens here, so it is going to change some stuff, potentially. Here we've got some tangential astigmatism still, although it is changing the shape a little bit. We're losing that sagittal bit as well. You've got more of a bulge in the middle and maybe a little bit sharper of a tail there. So it is actually maybe even correcting some of the sagittal astigmatism, if not the tangential. So that's interesting. And yeah, overall, this is an effect, right? This is something where you're going to do a time lapse, which is actually what I did on this night. I think these are all just frames from that time lapse. You know, what you can see here is crunchy. Once you're zoomed out here, and especially if the world's spinning, you really aren't going to notice, I don't believe. So yeah, that's interesting. And again, here's that 15-second exposure, wide open, no star trails. Could have pushed it, but I had a tracker, so there you go. And if we compare these two real quick, speed boosted on the left, obviously, we can see that we're not really getting image quality penalty, such as there would have been. Here we might even, like I said, we might even be getting a sort of better astigmatism, more useful, less V-shaped. I know what I plan to do with this lens, and I hope you found this useful. I'm not really going to bother with the develop module on this one. I don't really think we're going to apply profile corrections to a fisheye lens, but I hope you found this interesting. This is sort of a little pet project, and I hope at least somebody out there is as excited as I am about what can be achieved with a tool like this. And if you did enjoy this, I would really appreciate it if you did all the YouTube things. It really helps these videos get seen by more people, and there apparently are people out there who find them useful or valuable. So if you liked it, give it a thumbs up. I love hearing from people, so leave a comment. Really do appreciate it. Fortunately, you got to play the game so that YouTube actually shows it to more people, so that it just reaches more eyeballs and hopefully brings more people some information that they would not otherwise be able to find. So I appreciate that. Let's pop out of Lightroom and wrap it up. Well, what'd you think? Special use case, of course, for sure. But if you are the type of person with that use case, well, now you know how this lens does, and maybe that can help you go down your own weird DIY journey. So I hope you found that entertaining or interesting or informative. And I just want to thank you for putting up with me blabbing about this thing. I'm Darren, this is Fervent Astronomy. Hopefully we'll see you in the next one.